Good afternoon. So today we're going to carry on looking at our work on adding and subtracting fractions that we started last week, but we're going to kick it up a notch and make it a little bit harder today. So let's look at our learning objectives for today. To start with, we're going to recall how to find equivalent fractions that we did a few weeks ago. Then we're going to demonstrate how to add and subtract fractions with different denominators using equivalent fractions. And then hopefully some of you are going to start to predict how we might be able to add and subtract fractions when we can't use this method that we've been using today. So let's start with our equivalent fractions, our recalling of equivalent fractions. So you may remember that we did equivalent fractions 2 or 3 weeks ago, I think it was. Can you remember what an equivalent fraction was, what we use it for, and what it means? Can you just tell your screen what an equivalent fraction is? Okay, thank you for having a go. So an equivalent fraction are two fractions which represent the same amount but have a different denominator. So I've got some examples here with some missing numerators, some missing numbers on the top. So we're going to have just a quick recap on how we find equivalent fractions. I'm going to show you using some diagrams hopefully to help you as well. So our first one, our red one, is we have a half. So we have, if for example, a circle, and if I just shade in a half of that, I want to know that if I have the same circle, but instead of split into 2 sections, I split it into 4 sections, how many of those 4 sections do I need to shade in so that I've shaded in the same amount? So if I shade in the same amount, how many of those 4 sections have I shaded in? Tell me. I've shaded in 2, yeah. So the equivalent fraction is 2 over 4. And the reason, or the way in which we can work that out without having to draw the diagrams, is saying whatever we do to the bottom, we must also do to the top. So how do I get from 2 to 4? Mathematically, have I multiplied or divided, and by what? Yeah, so I've multiplied by 2. I cannot say I've added, so be careful there. So I've multiplied that by 2. So if I've multiplied that by 2, I must have done the same to the top. And 1 times 2 gives me the answer 2. So that's a slightly quicker way of working it out than drawing the diagrams. So let's have a look at my orange example. Again, I'm going to just draw it with a circle just to try and help you. And this time I've got thirds, and I want to shade in 1/3. And then on the right hand side, it's asking me to split that this time into ninths. So 3, well, these are terrible ninths, and ninths. And if I was to shade in the same amount of that diagram, how many of those how many of those ninths have I shaded in? Yeah, I've shaded in 3 of them. So again, that's the diagram way of working out that equivalent fraction. But if I was to do it just quickly, I can say, how do I get from 3 to 9? What have I multiplied by to get from 3 to 9? Tell me. Well, be careful. 3 times 3 is 9. And whatever I do to the bottom, I also do to the top. So 1 times 3 gives me my answer 3 that I have in the orange box. Okay, final example. Let's do this without the diagrams. Let's look at my denominator. How do I get from 7 to 14? What have I multiplied by? Use your times table grid if you're not very good at them. Good. So 7 times 2 is 14. And whatever I do to the bottom, I also do to the top. So 2 times 2 is 4, lovely. So my equivalent fraction is 4 over 14, and those fractions are all the same amount, just with a different denominator. And we're going to need this for today's lesson. So task number 1, in a second I'm going to ask you to pause the video. I'm going to ask you to click on the link Now, I don't think it's called equivalent fractions. I think it's just a link to a website, and it's a link to a game. And I want you to have a go at this game for me. Now, when you click on the link, it should take you to this website with a little hippo dude. And then if we scroll down, I want you to have a go at the second one, which is called equivalent fractions without models. And I want you to just have a go at doing some practice on your equivalent fractions to make sure that you've got that 100%. Once you're really confident, I'd like you to print screen me a score that you've got on that game so I can see how you've got on. So pause the video now and have a go at that game, please. Fantastic. Okay, so now you've had a go at practicing your work on equivalent fractions, let's get to the main part of today's lesson. So last lesson we started looking at adding and subtracting fractions, and we said that you have to remember that when adding or subtracting fractions we can only add or subtract the numerator, and therefore the denominators must be the same, and we looked at this last lesson. So here's a couple of examples from last lesson. So just quickly I'm going to remind you what we have to do. So if I have 1/5 add 3/5, I have to keep that fifths on the bottom. It's like saying 1 handbag and 3 handbags. How many handbags do I have? 1/5 and 3/5. And then I add the numerators. So I'm left with 4/5 or 4 handbags. Same with subtraction. I have 5/7 take away 2/7, so I want to know how many sevenths I have left. So my denominator stays the same as 7. And on the top I do 5 take away 2, which is 3. The two traps people fall into on these questions is they add the denominators, so they would tell me it was 4/10 for the first one. Or they add when they're supposed to subtract, and a few of you were adding instead of subtracting on some of the questions last lesson, so just be careful that you're reading the question carefully. So let's have a look then today if our denominators are different. And we're going to have a look at using our work on equivalent fractions to try and help us make these questions easier. So I'm going to start with this one on the left that says 1/4 add 5/8. So the first thing I need to do is I need to change one of the fractions so that they both have the same denominator. And I'm always going to try and go for the biggest denominator. So at the moment I can see 8 is my biggest denominator. So that's the one I'm going to go for. So I'm going to leave my second fraction as 5/8. I'm not going to change that question. But the first fraction, 1/4, I want to change that into something out of 8. I want to use an equivalent fraction. What do I times 4 by to get to 8? 4 times what is 8? Yes, 4 times 2. I'm going to put a little times 2 there, and that's why I've got an 8 on the next row. And whatever I do to the bottom, I also do to the top. So I'm going to do 1 times 2 on the top there. And 1 times 2 is 2. Lovely. So I've now rewritten the question so that it's really easy. What is 2/8? Add 5/8. 2 handbags. Add 5 handbags. How many handbags is that? It's 7. So my answer is 7/8. Let's have a look at the next example. So again, I've got two fractions that have different denominators. So I need to start by looking at what denominator they have in common. So I'm going to go for 6 because that's my largest denominator. So that means my first fraction, 5/6, is going to stay the same. This is a takeaway, so don't forget that. And then my second fraction, I want to make that out of 6 as well. So I need to look at my fraction 1/3 and I need to decide what equivalent fraction will give me a denominator out of 6. So what do I do to 3 to turn it into a 6? What can I do to 3 to turn it into a 6? I can times it by 2, well done. So 3 times 2 is 6, that gives me my new denominator, and whatever I do to the bottom, I also do to the top. So 1 times 2 is 2. And I now have the same question, but just written a little bit easier. So 5/6 take away 2/6. What's my denominator? That doesn't change, that stays 6. So 5 giraffes, take away 2 giraffes. How many giraffes do I have left? 5 6, take away 2 6. That leaves me with 3 6. And that is my final answer. You might want to pause the video just to write down those examples so you've got something to refer back to for the next task. So in a second I'm going to ask you to pause the video. I'm going to ask you to go back onto the classroom, find the Google form that is called Task 2, adding and subtracting fractions using equivalent fractions, and I want you to have a go at the questions on there for me. I'm going to look at these, so if you think you've got it right and you've maybe just pressed the wrong button, so you've used the wrong fraction symbol, for example, I can correct those marks. So I want you to have a go at those and I will check your scores afterwards. Can you pause the video now? Okie dokie. So hopefully you've started to get the hang of these. So for the last part of the lesson today, we're going to do what we did last lesson as well. And we're going to look at being able to answer fractional addition and subtraction questions when they're written as a word problem. And we did some of these last lesson as well. So all I'm going to do is I'm going to do exactly what we've just done. I'm going to write out the fraction question, but I've just got to extract the information first. So my two examples, the first one says, you give 1/7 of a box of cupcakes to Jamie and 5/14 of the box of cupcakes to Nick. So there's my two fractions. How much of the box of cupcakes did you give away? So if I gave 1/7 to Jamie and 5/14 to Nick, I need to add those together. So I'm going to do 1/7 add 5/14. At the moment, they have different denominators, so I can't work it out just yet. So I need to choose the larger denominator, which is 14, which means 5/14 is going to stay the same. And it means 1/7 is going to change to something over 14. Using my equivalent fractions, what do I do to 7 to get to 14? What do I times by? Tell me. Yeah, it is 7 times 2, and whatever I do to the bottom I also do to the top. So on the top of that fraction I have 1 times 2, which is 2. I've now got a much easier version of the question, and I can do 2/14 add 5/14, and that gives me the answer 7/14. I gave away 7/14 of my box of cupcakes. My second example from these word problems says a bottle contains 7/9 of a litre of Cherryade. I don't know if you've ever tried Cherryade. It's quite nice, like a red fizzy pop. And after you pour after you've poured 1/3 of a litre into the glass, how much is left in the jug? Oh, I think this should say how much is left in the bottle. The typing error there. Okay, so my two fractions that I have for this question are 7/9 and 1/3. And if I had 7/9 and I poured out 1/3, that means I am subtracting 1/3. So I'm just going to write that again. So I had 7/9 and I poured out 1/3. So again, I've got fractions with different denominators. So I'm going to look at which is my larger denominator, and that is 9. So that means 7/9 is going to stay the same, and my second fraction is going to change to something over 9. What do I times 3 by to get to 9? 3 times something is 9. 3 times 3, lovely. And whatever I do to the bottom, I also do to the top. So 1 times 3 is 3. And again, I've now got a much nicer question to answer. What is 7/9? Take away 3/9. The answer is 4/9. And that's how much is left in the bottom. Again, you might want to pause the video to write down those examples to refer back to. So, final task for today. When the video ends, I'd like you to go back onto the classroom, have a find of task 3, fractions in context. It's another Google form, very similar to what we did last week. You might find you want to write some answers on paper before you put your answers into the Google form, just to make sure that you're doing your working out. Remember, the fractions must have the same denominator first. Good luck.